Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine you are running a huge shopping application. The website is still online. Customers can still open the application. But orders are taking 10 seconds instead of 1 second. Some payments are failing. Database CPU is reaching 95%. And customers are starting to complain. Here's the question. How does a solution architect know what's actually going wrong? You can't sit there watching every server, every API and every database. You need your architecture to tell you what's happening. And that's where Azure Monitor comes in. Without proper observability, troubleshooting becomes detective work. Is the application available? Fast? Throwing errors? Running out of resources? Having database problems? Receiving unusual traffic? Then introduce the three big categories: metrics, logs, traces. Metrics are numbers that tell us how a system is behaving. Metrics are like the dashboard of your car. Speed, fuel, engine temperature. You don't need to inspect the engine every second. The dashboard tells you what's happening. Logs tell us what happened inside the application. Metrics is equal to dashboard. Logs is equal to diary. Consider a standard microservices flow. A user request hits the customer frontend, routes through the API gateway, calls the order service, triggers the payment service, and finally writes to the database. Looking at the execution path, a single request breaks down like this. The API gateway takes 20 milliseconds. The order service takes 40 milliseconds. The payment service takes 900 milliseconds. And the database finishes in 30 milliseconds. Clearly, it is the payment service where it is getting delay. This is where tracing becomes necessary for solution architecture. Let's zoom out to the core infrastructure, Azure Monitor. Azure Monitor provides a centralized way to collect, analyze, and act on telemetry from your Azure resources and applications. It processes this data through three primary pillars: metrics, which track numerical performance data over time; logs, which record detailed system events and histories; and alerts, which immediately flag anomalies, allowing you to automate scaling, trigger self-healing scripts, or alert engineering teams before performance degrades. A common misconception is that Azure Monitor is just a single, static dashboard. It is not. It is a massive, distributed telemetry fabric divided into three core pillars: metrics, logs, and alerts. Each pillar maps to distinct, specialized engines. Metrics handle resource monitoring, tracking live numbers like how busy your computer's brain is. Logs flow into a log analytics workspace, acting like a detailed diary that records every single event. And alerts manage your notifications, sending you a text or email if something breaks. Right next to these is Application Insights, a special tool that looks inside your code to see exactly how your app is behaving. The most important thing to remember as you start learning is that different Azure services contribute different telemetry. This just means that a virtual machine, a database, and a website will all share different types of information to help you see the full picture. Let's understand how Log Analytics Workspace fits into Azure monitoring. First, we start with Azure resources. These are your applications, virtual machines, and services running in Azure. Next, they produce telemetry. That's all the data about performance, usage, and activity. This telemetry flows into the Log Analytics Workspace. Think of it as a central hub where logs are collected. Inside the workspace, we use KQL queries, a special language to search and analyze the logs. Finally, we get insights, clear information that helps us monitor, troubleshoot, and improve our systems. If Azure Monitor is the monitoring ecosystem, Log Analytics Workspace is one of the important places where we collect and query logs. Now let's make this practical with a simple KQL query. Here we are asking, from the last 1 hour, how many requests happened, grouped by their result code. Notice how short and readable this is, just a few lines instead of scrolling through thousands of raw log entries. We are not going to turn this into a full KQL course today. I just want you to see that architects and engineers can query telemetry directly, instead of manually reading endless logs. Now let's look at Application Insights. Application Insights is focused specifically on application-level telemetry. That means it collects data about how your app is behaving, requests coming in, dependencies it calls, exceptions that occur, performance metrics, and even availability checks. This gives developers and architects a clear window into the health of the application itself, not just the infrastructure around it. Enough theory. Let's open Azure Portal and see what production monitoring actually looks like. Let's start by opening Azure Monitor. Head up to the top search bar, type Monitor, and click the service. This brings you straight to your global telemetry command center. First up is Overview. This gives you an instant, high-level snapshot of your entire infrastructure's health at a single glance. Next, click Activity Log. This is your audit trail. It tracks subscription-level events, showing you exactly who modified what resource, and when. Moving down to Alerts. This is where you manage your proactive rules and action groups, making sure you catch system anomalies before your users do. Now, let's open Metrics. This launches the Metrics Explorer, allowing you to chart real-time numerical performance data like CPU usage or memory spikes. If you need to dig deeper, click Logs. This opens up your Log Analytics workspace, where you can run powerful custom queries to slice and dice your raw data. Now, let's pivot from infrastructure to application performance. Search for Application Insights and click into your application's dedicated resource. Open up the application map. Look at this, a live, visual topology of your architecture. It automatically charts your components, call volumes, and dependencies so you can spot failing nodes instantly. Next, check out Live Metrics. This is near zero latency, updating every single second. It's perfect for watching incoming requests and exceptions right after a new code deployment. Imagine the CPU usage of a server goes above 80%. If it stays that way for more than 5 minutes, an alert is triggered. That alert is sent directly to the operations team, who can investigate and take action. Monitoring becomes useful when it leads to action. The request flows through the front door, API, order service, payment service, and finally the database. Now, let's see what Azure Monitor tells us. Everything looks fine except the payment service, which is unusually slow. So we dig deeper with Application Insights. Here we see the payment service calling an external payment API, and that's where the timeout occurs. This is the kind of real troubleshooting story that makes monitoring memorable. Monitoring isn't just about dashboards, it's about finding the problem and fixing it fast. Monitoring versus observability. This is an important architect concept. Monitoring. Is something wrong? Observability. Why is it wrong? This also sets up our future Observability Explained topic. Anyhow, we have already covered observability in great detail using real-world architectural concepts in Solution Architect Masterclass playlist. Now let's talk about alerts. It starts with a metric, like CPU usage, error rate, latency, or availability. Next, we define a threshold, for example, CPU greater than 80%. Then we create an alert rule. This watches the metric and checks if the threshold is crossed. When the rule is triggered, it calls an action group, a set of responses like sending an email, posting to teams, or kicking off automation. Good alerting is about actionable signals, alerts that point to real issues and drive a response. It's not about generating thousands of noisy alerts that overwhelm the team. If your team receives 500 alerts every morning, eventually people stop paying attention. This is the classic architect's mistake. More alerts does not mean better monitoring. That's alert fatigue, and it makes monitoring useless. The right approach is to focus on important signal. Let's put everything together and see how monitoring flows in a real application. Users connect through Azure Front Door, which routes traffic to the application. Inside the application, requests may go to an API, functions, or AX services. All of this activity is observed by Azure Monitor, which collects metrics, logs, and traces. These flow into log analytics and application insights, where we can query, analyze, and visualize telemetry. From there, we define alerts, signals that matter, and send them to the operations team for action. This is the complete monitoring pipeline, from users, through the app, into Azure Monitor, and finally into insights and alerts that drive real responses. When designing monitoring, an architect doesn't just pick services, they ask the right questions. Start by deciding which parts of the system matter most. Is it the app itself, the servers, the database, or the network? Next, define the signals. Are we measuring uptime, speed, error rates, or capacity limits? Not every metric needs an alert. Alerts should only fire when action is required. Alerts must reach the right people, the team who can actually fix the issue. Finally, think about the response. Does the team follow a runbook, trigger automation, scale resources, or start incident management? This is architecture thinking, structured decisions about monitoring. It's not just memorizing Azure services, it's designing a system that works when things go wrong. If you remember only one thing from today's video, remember this. Monitoring tells you something is wrong. Observability helps you understand why. Azure Monitor gives us the tools to collect telemetry, analyze it, create alerts, and troubleshoot our applications. And as a solution architect, your job isn't simply to build the application. You also need to design how that application will be observed when things go wrong. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.